Hi everyone, I'm John Camera, Manager of the Applications Lab here at Instron, and in this video, I'll be introducing you to universal testing machines. By the end of this video, you will understand the basic parts of a testing system, how to power it on, and the primary safety features of this equipment. Before we dive in, I do want to mention a few important notes. This video is not meant to be used as a replacement for training. Think of it more as an introduction to the testing system. And each of our testing systems come with an operator's guide that includes important safety information that should be reviewed prior to using the equipment. If you don't have the operator's guide for one of the systems in your lab, you can download a copy from our website at instron.com. These machines are basically very simple. They're designed to apply force to a specimen in a variety of ways, such as pushing, pulling, or twisting. What makes them special is how precisely they can measure the forces being applied, and how the data from these tests can help you predict how the specimen will perform in everyday use. The body of the machine is called the frame, and this piece here is called the crosshead. There are also accessories and a computer that controls the frame. This particular frame is a single column model with a maximum load capacity of 5 kilonewtons. We also have dual column tabletop and floor models with much higher force capacities, but all of them work basically the same way. Now let's take a look at the side of the machine where we can see a few wires. This is where all of the accessories, including load cells and extensometers, plug in to relay information over to our software. These are called signal conditioner modules, or SCMs. On the back of the system, we have our power switch. Once we flip this switch, our system will go through a self-test before it's ready for use. While it does that, we can turn on our computer that we call the operator dashboard. We then open the Blue Hill software and wait for our system to start before we begin. The moving part of this testing system is called the crosshead. Not only does it move up and down during testing, you'll also need to move it in order to load and unload specimens. Now before we go any further, I want to point out this big red button. This is our e-stop, also known as the emergency stop button. If for any reason you need to stop the movement of the frame, just hit this button and the crosshead will immediately stop moving. Once you've decided it's safe to re-enable movement, you can just twist the e-stop and the button will pop back up. Then you just need to re-enable the frame and the software, which will allow you to move the crosshead and continue testing again. There are two options for moving the crosshead. The first are the up and down buttons on the handset. These will allow you to jog the crosshead up or down at a safe pace and are designed to be used for larger movements. The second method is this thumb wheel, which offers much smaller movements for when you need more precision. So you'll likely use a combination of both to reset your crosshead between tests. Now let's look at our load string, which is what we call the series of connected accessories between the crosshead and the base of your frame. Every load string begins with a load cell, and its job is to measure the forces that our specimens experience during testing. The most important thing to know about a load cell is that you can never run a test with forces expected to exceed this number here. Each load cell is labeled with a force capacity. This one is 5 kilonewtons, which means the maximum load it can safely be used for is up to 5 kilonewtons. Subjecting your load cell to forces above this number will either damage or destroy it. Also keep in mind that the weight of your fixtures could reduce the full capacity of your load cell, leading to unexpected damages. It's also important to make sure that your load cell never exceeds the capacity of the test frame itself. In this case, the 5 kilonewton capacity of our load cell matches the 5 kilonewton capacity of our testing frame, which is appropriate. If we need to measure lower forces with this system, we can safely use a lower capacity load cell, such as a 50 newton capacity. But we should never use a 10 kilonewton load cell, which would exceed the capacity and damage the system. Before we move forward, let's cover the calibration of a load cell. We recommend going through the calibration process once per shift or every 8 to 12 hours. Next, I want to talk about grips. The type of grip or fixture is going to determine what test you're able to perform. And you can change out these fixtures if you need to test something new. We currently have a pair of 1 kilonewton pneumatic side action grips installed. Again, the 1 kilonewton designation indicates the maximum load these grips are designed for. Since 1 kilonewton is smaller than our load cell's capacity of 5 kilonewtons, this is an acceptable configuration. These grips can be easily swapped out for another type of fixture depending on your application. Each grip has a set of jaw faces. These come in a variety of sizes and surface finishes to accommodate different material types or component geometries. You can see we also have shields installed. These are here to protect the operator from finger pinches when closing the jaw faces. we've also installed a specimen alignment device that makes loading specimens easier and ensures consistent results. Since these grips are pneumatic, we also have an air hose that runs between each grip and the air kit that supplies the compressed air to actuate the grips. To open and close the job faces, you have a couple of options. You can either flip the switch on each grip, or what I find to be more convenient is using a foot switch. And finally, we have our limit switches. You'll find these located on the right-hand side of your frame. It's very important to set these prior to testing to prevent your grips and fixtures from colliding when the crosshead is moving. And that's a high-level look at the important components of your universal testing system. Before you move on to actual testing, please make sure you consult your lab manager for detailed instructions on how you should be setting up and running your material or product tests. For more information about the specific system in your lab, I recommend reviewing the operator guide that came with the frame. You can also download a copy from Instron.com. Thanks for watching.